Hi, I'm Julian Giuca, the CEO of Datable, and this is Loaf. Observability costs. They sell this idea of fear. You need to monitor everything. You need to capture everything. What happens if the boogeyman comes? What happens if you're breached? What happens if someone has a sale and you don't capture that sale? We're in this world where you need to capture everything or else. And they're also not wrong. If you're not monitoring your application, you have no idea what is happening in your application on the internet. So why is observability the second most expensive part of running an application on the internet? It doesn't really make a ton of sense to me, and I've been working in this space for 15 years. So fundamentally, it's all about how much data you're collecting. All of these vendors do consumption-based pricing. If you're running a busy application on the internet, ideally you're paying more than someone who's running a small application on the internet. Seems great, but if we keep coming back to this fear-based sale model of you've got to catch it all, you've got to collect it all, you suddenly have a whole lot less control over the data that you're sending over there. They don't give you guidelines, and in many cases, when it comes to things like application performance monitoring, they're actively doing the harvesting and collection of data. You don't even play a part in what's being collected. So we're going to talk about where observability began, how it used to work and how it collected all that data, how it is now and how it got to here, and how we're going to help manage all of that data collection. The origin of observability all boils back to log data. Logging is the first thing that anyone has when they write software. You spin up your application, it says, hello world, hey, that's actually a log line. And as software got more and more complex, you have more log lines that come out of the system. Hey, I've received a request, it's in a database. Each of these load balancers, databases, your application, each spit out log data that says what's happening. It's this record of how is your system behaving. And as software got more complex, that stopped working. Using log data as a mechanism to understand what's happening in your system is really hard. I'm sure all of the developers at home have tried puts-driven development before, where you add, have I reached here, have I reached here, have I reached here? And doing that as a mechanism of like production debugging, that's really hard. So we needed a better system. Log data is great, but we needed more. And so it went from log data to log data plus traces, log data plus metrics. These two different data types had different origin stories unto themselves. Trace data is what is happening as a request goes into your system and does that request response lifecycle and comes back out. It's like X-ray dye back in the old cartoons where the patient walks up and has an X-ray and you see the ink pass through their system. That's what a trace is. And that's fantastic for developers because developers get to say, oh, an error was thrown here, like specifically just there, or the request did this and that's weird, and why is it spending a bunch of time there? So you get this extremely rich picture, but the utility of that data is quite limited. It's only really good for developers, and it's super chatty. And then you've got metric data. Metric data is really valuable to your SREs, to your ops people. That tells stuff over time. So imagine taking your temperature and taking your temperature again and taking your temperature again. That's your metric data. It's 101.5, then it was 101, then it was 98. And so you have this visualization, this time series of metric data over time, that's temperature over time. You put all of this together and it's an inordinate amount of data. And all of it is slightly different, but it gives you this full picture of what is happening in your application. So we've gone on this journey where we started with log data, we've added trace and metric data, we've added more data, and then our requirements of that more data have gone up. We want it to be faster, we want it to be more responsive, we want to get insights immediately. And then we went through this big phase of microservices. So everything's gone from this big monolith Ruby on Rails app or Spring app into, hey, let's go and do microservices, let's go and do Kubernetes. And instead of having one big thing to monitor, you now have tens of thousands of small things to monitor. And all of that stuff has its own metadata, all of that stuff has its own signal, and the complexity of monitoring that went to the moon. So your business is doing well, it's growing, you're getting more customers, you're going to need more infrastructure in order to support that growth of the business. You're going to need more Kubernetes pods, you're going to need more AWS, you're going to need more load balancers. All of this stuff just amplifies. And that's how we end up in this universe where observability data, observability spend is growing 30% year on year, even though the value it's delivering is stagnant. Another thing which we hear about on a pretty regular basis, this happened not that long ago, is observability vendors increase their price. It's that inflation tax that went around last year. Everyone increased their prices. And so what was 30 cents a gig is now 35 cents a gig. That was a nice solid 15% increase that they sent an email about. It just happened. Nothing changes on your end. You haven't changed your behavior. Your server hasn't changed its behavior. It's doing what it was always doing. You haven't updated the library. It's just now that's a 15% increase. You're spending $100, it's now $115. That sucks. what are you gonna do? You can't turn this stuff off. You can't churn vendors. You're locked in. You need that observability. You need to know that your system's working. But equally, like, what's stopping them from doing it again? Hint, they will do it again. You can use Datable. We use all of these observability vendors to make sure that we work with them. Most recently, one of them raised their prices by 15%. We just turned down the volume of data that we were sending by 15%. That was neat. Our bill stayed the same. When I first started working in the observability space, this was the start of 2011. I worked at one of the larger observability companies, and the way that they and all of their competitors did pricing at the time was on CPU-based pricing, which meant that if you've got more CPUs, you've got more capacity to run more threads of that application. Big monolith era. And this is before cloud really took off. So we're talking about rack-mounted servers. Is this like a 8-core or 4-core, 2-core? And this is how the pricing worked. Most people moved into cloud. And now this idea of, well, you're charging by CPUs, number of CPUs, doesn't make sense because I spun up an additional 10 servers because we had a sale on Friday, and then I spun them down on Saturday because the sale was over. But the pricing model is this, like, you pay for 100 server license for the year. And so the pricing model and the reality of how software was running shifted. This happened to a lot of vendors out there. A lot of vendors who wanted to be very competitive in pricing ended up all being pulled in the same direction, which was we can no longer predict how people run their software. Everything is becoming more ephemeral. Back in 2011, everything was more designed around frameworks. It was things like Spring and Ruby on Rails. They were these staple monoliths that you understood how they behaved. And we've shifted into now everything is a microservice and everything is bespoke. It's no longer a framework. You have to go and look at how these businesses run, what their operational costs are. Ultimately, the most expensive thing for all of these businesses is compute. It's not storage. Storage is nothing. And what are you computing? It's on volume of data. So we've gone from this model where everything was just a license. You got a server, we'll charge you for a server, it's just a license, to now these very variable, like, oh, it's Black Friday, well, that's going to cost you extra. And so the pricing model of these things are all consumption-based, and it all wildly ebbs and flows depending on how active your application or server is. The downside of all of this, I've been on calls with customers where they're just like, hey, we had a denial of service attack last night. Turns out we're going to have a multi-$1,000 observability spend because we had a denial of service attack that spiked the number of events that we were collecting. That sucks. That's completely unfair. Ultimately, you need to take control of your data. This can take many forms, but the ideal case here is you're looking at your data, you build a data strategy, and you're making some decisions. All of this data doesn't need to end up with these expensive vendors. Go and stick some in S3, go and stick it in an on-prem Elastic. Look at your data and make these trade-offs. Then you'll just notice all of these vendors, even when they raise their price, you get a little reverse Uno card in your pocket, problem solved.